participation will get a bonus point. Okay, group 10, you may start.
Okay, thank you, ma'am. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. That I respect is Ma'am Melia Sari as the lecturer of Mathematics English Course 1 and all of my friends. Let me introduce myself. My name is Kalista Cahaya Fairuzara as a moderator in today's presentation. The topic that will be discussed at today's presentation is metrics and will be present by the group 10, Elvira, Dewi, and Hanifa. Before we start the presentation, I would like to read the sequence of this group presentation today. This group presentation is divided into 5 sessions. First, opening, second, presentation, third, discussion and Q&A session, fourth, evaluation, fifth, quiz session, sixth, closing. Now let's sing Basmalah together. Bismillahirrahmanirrahim. And now move on to the presentation. For group 10, times is yours.
Izin mengabari, Ma'am. Jadi ada satu anggota dari kelompok yang laptopnya mati karena overheat, jadi lagi dinyalain lagi mungkin.
Okay.
Maaf ya, Ma'am, tadi laptopnya mati.
Yeah, can you start now?
Yes, I can.
Okay, go ahead.
Okay, thank you, moderator. Assalamualaikum warahmatullahi wabarakatuh. Good morning, Ma'am Melia Sari and friends. We are from Group 10. Today, we'd like to present and discuss about matrix. Before we start our presentation, let me introduce my team members. There are Elvira Nur Ilahi, Hanifah Rena Zulfa, and the last one is Dewi Sri Mulya. In this topic, we will present about definition of matrix, types of matrices, and matrix operations. Without any further ado, let's turn to the first topic. It's about definition of matrix. Matrix is a rectangular array of numbers arranged in rows and columns bounded by bracket. The bracket can be either regular bracket or square bracket. Rows are horizontal numbers while columns are vertical numbers. A matrix is named with a capital letter such as A, B, C, etc. Numbers arranged in a matrix are called elements of the matrix. The elements of the matrix are denoted by lowercase letters and given an index that states the location of the rows and columns. The size of the matrix is called the order. The order of matrix is based on the number of rows by the number of columns in the matrix. So, if a matrix A has m rows and n columns, then the order of matrix A is m by n. To make it simpler, it can be written with the order m by n like this. For example, matrix A has 5 rows and 5 columns, so the order is 5 by 5, or it can be written like this. Then the elements of the matrix A can be denoted by element Aij, which represent the elements of the matrix A in the 8th row and j column. Consider the following matrix like this. This can be concluded A. The order 1 by 1 represents the matrix element A in the first row of the first column. The value is 0. A. The order 1 by 2 represents the matrix element A in the first row of the second column. The value is 1. A. The order 5 by 4 represents the matrix element A in the 5th row of the fourth column. The value is 2. Okay, next, types of matrices. The first types of matrices is row matrix. Row matrix is a matrix which has a single row. Example, like this, A, 2, 4, 5 is a row matrix of order 1 by 3. Z, 1 and 8 is a row matrix of order 1 by 2. The second types of matrix is column matrix. Column matrix is a matrix which have a single column. For example, A 2, 5 is a column matrix of order 2 by 1. And L 0, 8, 2 is a column matrix of order 3 by 1. As you guys can see, there is a difference of a row matrix and column matrix. Okay, the third types of matrix is zero matrix. Zero matrix is a matrix which all of the entire are 0. Example like this, zero matrix which all the integers are 0. So the example is a zero matrix of order 3 by 2. The fourth type of matrix is square matrix. Square matrix is a matrix which has the same number of rows and columns. Example, D1495 is a square matrix of order 2 by 2. The main diagonal elements of their matrix are 1 and 5. As you guys can see in matrix D, 1 and 5 in this matrix as a main diagonal of elements. And there's a matrix K, 3, 4, 1, 6, 2, 5, 3, 9, and 8 is a square matrix of order 3 by 3. The main diagonal elements of their matrix are 3, 2, and 8. The last example of diagonal matrix is as matrix C, 1, 3, 8, 4, 6, 2, 7, 5, 4, 0, 5, 9, 9, 7, 2, 3 is a square matrix of order 4 by 4. The main diagonal elements of the matrix are 1, 2, 5, and 3. Square matrix, I mean. Okay, next, a diagonal matrix. Diagonal matrix is a square matrix whose elements other than the main diagonal are 0. For example, R 1008 is a diagonal matrix of order 2 by 2. And the second example is matrix S 200080005 is a diagonal matrix of order 3 by 3. You guys can see the other elements elements other than main diagonal are 0. This matrix named diagonal matrix. Next, identity matrix. Identity matrix is a square matrix which all the entire on the main diagonal are 1 and all other entries are 0. The identity matrix denoted as I. For example, like this, the first example is an identity matrix of order 2 by 2, and the second sample is an identity matrix of order 3 by 3. Next, scalar matrix. Scalar matrix is a square matrix having a constant value for all the elements of the main diagonal and the other elements of the matrix are 0. For example, see 8 0 0 0 8 0 0 0 8. This matrix has a constant is 8. Scalar matrix formula. There is formula for scalar matrix. Constant by identity matrix equal to scalar matrix. The formula is like this. Next, triangular matrix. Triangular matrix is a square whose elements above or below the main diagonal are all 0. There's two types of triangular matrix. The first type is upper triangular matrix. Upper triangular matrix is a square matrix whose elements below the main diagonal are all 0. As you can see the example in here, the first example is upper triangular matrix of order 3 by 3. And the second example of upper triangular matrix is upper triangular matrix of order 4 by 4. The last one is lower triangular matrix. Lower triangular matrix is a square matrix whose elements above the main diagonal are all 0. This example of lower triangular matrix matrix O is a lower triangular matrix of order 3 by 3, and a matrix M is triangular matrix, lower triangular matrix of order 4 by 4. Okay, the next topic is matrix operation.
Okay, next is matrix operation. Matrix operation mainly involve three algebraic operations, which are addition of matrices, subtraction of matrices, and multiplication of matrices. Addition, subtraction, and multiplication are the basic operation on the matrix. To add or subtract matrices, this must be of identical order, and for multiplication, the number of columns in the first matrix equals the number of rows in the second matrix. Next. Next is addition of matrix. If matrix A, which contains the elements A, I, J, and the order is m by n, and matrix B, which contains the elements B, I, J, and the order is m by n, are two matrices of the same order, then their sum A plus B is a matrix, and each element of that matrix is the sum of the corresponding elements. That is, A plus B is equal to elements IAJ and the plus BIJ and the order m by n. To consider the two matrices A and B of order 2 by 2, then the sum given by like this, as you guys can see in our presentation. Next. Next is the properties of matrix addition. If A, B, and C are matrices of same order, then the first is commutative law. A plus B is equal to B plus A. 2. Associative law. A plus B, the sum of A plus B is added to C is equal to A plus the sum of B plus C. 3. Identity of the matrix. A plus O is equal to O plus A is equal to A, where O is zero matrix, which is additive identity of the matrix. For additive inverse, A plus minus A is equal to 0 is equal to minus A plus A, where minus A is obtained by changing the sign of every element of A which is additive inverse of the matrix. 5. C is equal to B, where A plus B is equal to A plus C, or B plus A is equal to C plus A. And 6. Trace of matrix A plus minus B is equal to trace of matrix A plus minus trace of matrix B. And 7, if A plus B is equal to 0 is equal to B plus A, then B is called additive inverse of A, and also A is called the additive inverse of B. Next. For example, is consider the following matrices as known. Matrix A is 2, minus 1, 3, 0, minus 5, and 2. Matrix B is 1, 6, minus 1, minus 2, 0, minus 3, and matrix C is 4, 4, minus 3, 0, minus 1, and minus 2. Which two can be added? What is their sum? Since only matrices of the same size can be added, only the sum A plus B is defined. Because it cannot be added to either A or B, the sum of A and B is, as you guys can see, like this. Since addition of real numbers is commutative, it follows that addition of matrices when it is defined, it also commutative. That is, for any matrices A and B of the same size, A plus B will always equal B plus A. Next. Okay, this is a subtraction of matrices. If A and B are two matrices of the same order, then we define B subtracted by A is equal to A plus minus B. Consider the two matrices A and B of order 2 by 2, then the difference is given by matrix A1, B1, C1, D1 subtracted by A2, B2, C2, D2 is equal to, and the answer is A1 subtracted by A2, B1 subtracted by B2, C1 subtracted by C2, and D1 subtracted by D2. We can subtract the matrices by subtracting each element of one matrix from the corresponding elements of the second matrix. That is, a matrix B subtracted matrix A is equal to elements Aij subtracted by Bij, and the order is m by n. Next. And for example, consider the following matrices as known. Matrix A is minus 1, 2, 0, 4, 1, and 10. Matrix B is 3, 2, 4, 0, 8, and 16. What is the subtraction behind A and B? You can see the presentation. So matrix A subtracted by matrix B, the answer is minus 4, 0, minus 4, 4, minus 7, and minus 6. Next. Next is scalar multiplication of matrix. If matrix A, which contains the element Aij and the order is m by n, is a matrix nk any number, then the matrix which is obtained by multiplying the elements of A by K is called the scalar multiplication of A by K, and it is denoted by Ka, like this. And the properties of scalar multiplication: if A and B are matrices of the same order and lambda and mu are any two scalar, then as you guys can see here, this is some properties of scalar multiplication. And for example, if matrix A is 1, 0, minus 3, minus 2, 4, and 1, then the scalar multiple to A is obtained by multiplying every entry of A by 2. So matrix A multiplied by 2. So the answer is 2, 0, minus 6, minus 4, 8, and 2. Next. This is a matrix multiplication. If A and B be any two matrices, then their product AB will be defined only when the number of columns in A is equal to the number of rows in B. If A is m by n and B is n by p, then the product AB is defined, and the size of the product product matrix AB will be M by P. Next. This is the example. The supposed matrix A is A, B, C, D multiplied by B multiplied by matrix B is J, K, L, M. So the formula will be matrix A multiplied by matrix B. So the answer is AG plus BL, AK plus BM, CG plus DL, CK plus DM. Next. This is the properties of the matrix multiplication. The first is matrix multiplication is not commutative in general. That is, in general, AB not equal to BA. And two, matrix multiplication is associative. AB into C is equal to A into BC. And three, matrix multiplication is distributive over matrix addition. That is, A into B plus C is equal to AB plus AC and A plus B into C is equal to AC plus BC. And for if A is an M by N matrix, then I, the order is M, A is equal to A, and equal to A, I, the order is N. 5. The product of two matrices can be a zero matrix while neither of them is zero. That is, if AB is equal to 0, it is not necessary that either A is equal to O or B is equal to 0. 6. If A is an M by N matrix and O is a zero matrix, then A the order M by N multiplied by O, the order M by P is equal to O, the order M by P. The product of the matrix with a zero matrix is always a zero matrix. 7. If AB is equal to 0, does not mean that A is equal to 0 or B is equal to 0. Again, the product of two non-zero matrices may be a zero matrix. If AB is equal to AC, then B not equal to C. But cancellation law in not applicable. 9. Trace AB is equal to trace BA. And the last is there exists a multiplicative identity for every square matrix such AI is equal to IA is equal to A. Next. For example, given the two matrices, determine which matrix product AB or BA is defined and evaluate it as known. Matrix A is 1, 0, minus 3, and matrix B is 1, minus 2, and 0. Since A is 1 by 3 and B is 3 by 1, the product AB in that order is defined and the size of the product matrix AB will be 1 by 1. The number of columns of the first matrix must match the number of rows of the second matrix in order for their product to be defined. Taking the dot product of first row in A and first column in B gives the 1 by 1 and entry in AB. So, matrix A multiplied by B is 1 multiplied by 1 plus O multiplied by minus 2 plus minus 3 multiplied by O. So the answer is 1.
Okay. Next operation, matrix transpose. The transpose of the matrix is found by interchanging its rows into columns or columns into rows. The transpose of the matrix is denoted by using the letter T in the superscript of the given matrix. For example, if A is the given matrix, then the transpose of the matrix is represented by like this. We read transpose of matrix A. The following statement generalizes the matrix transpose. If matrix A, which contains the element Aij and the order is m by n, then transpose of matrix A, which contains the elements Aij and the order is n by m. How to find the transpose of the matrix? Consider an example. If a matrix is 2 by 3 matrix, it means it has 2 rows and 3 columns. While finding the transpose of the matrix, the elements in the first row of the given matrix are written in the first column of the new matrix. Similarly, the elements in the second row of the given matrix are written in the second column of the new matrix. Consequently, the order of the new matrix becomes 3 by 2 as it has 3 rows and 2 columns. If A has the elements A, B, C, D, E, F, and the order 2 by 3, then transpose of the matrix A is A, D, B, E, C, F. The order is 3 by 2. For the example, find the transpose of the given matrix. As now, matrix M has the elements like this. Solution, give a matrix of the order 4 by 3. The transpose of matrix is given by interchanging rows and columns. And then, transpose of matrix M is 2, 13, 3, 4, minus 9, 11, 6, 13, 3, minus 17, 15, and 1. Properties of matrix transpose. 1. Transpose of the sum A plus B equal to transpose of matrix A plus transpose of matrix B. 2. Transpose of matrix A equals matrix A. 3. Transpose the product of scalar K multiplied by matrix A equals scalar K multiplied by transpose of matrix A. 4. Transpose of the product of A multiplied by B equals to transpose of matrix B multiplied by transpose of matrix A. Determinant of matrix. The determinant of the matrix is the value obtained from the square matrix. This determinant is a function that will map a square matrix to real number. The value of the determinant is symbolized by like this. For example, matrix A, the value of the determinant becomes determinant A is equal to determinant of matrix A. Formula of matrix determinant for order 2 by 2. The trick is to multiply the elements on the main diagonal, then subtract the elements on the secondary diagonal. See the picture to following for easier understanding. For example, if matrix A has a number 4, 2, 3, 5, then determinant of matrix A is the product of 4 multiplied by 5 minus the product of 2 multiplied by 3 is 20 minus 6 is equal to 14. Formula of matrix determinant for order 3 by 3. First, Sarus method. This method can only be used on matrix of order 3 by 3. For example, there is a matrix A of order 3 by 3 as follows. As known, matrix A like this. What is the determinant of matrix A? The first step, write again the elements in the first and second column to the right of matrix A. Then multiply the elements of the matrix according to the pattern Pay attention to the color, pattern, and design. Look at the following picture for easier understanding. For the picture, for the picture can be concluded determinant of matrix A is A1, the product of A11 multiplied by A22 multiplied by A33 plus the product of A12 multiplied by A23 multiplied by A31 plus the product of A13 multiplied by A21 multiplied by A32 minus multiplied by A13 multiplied by A22 multiplied by A31 minus the product the difference A11 multiplied by A23 multiplied by A32, then the minus A12 multiplied by A21 multiplied by A33. For the example, if matrix A has the numbers 1, 2, 3, 2, 1, 4, 3, 1, 2, then the determinant of matrix A is the product of 1 multiplied by 1 multiplied by 2 plus the product of 2 multiplied by 4 multiplied by 3 plus the product of multiplied 3 multiplied by 2 multiplied by 1 minus the product of 3 multiplied by 1 multiplied by 3 minus the product of 1 multiplied by 4 multiplied by 1 minus the product of multiplied 2 multiplied 2 multiplied 2 is equal to 2 plus 24 plus 6 minus 9 minus 4 minus 8 is equal to 11. Determinant of matrix 2. Minor cofactor method. From the matrix A above, we remove the element A, meaning the matrix element A to ij. For example, we want to select A12, it means we have to remove the first row and second column. Look at the following picture for easier understanding. From the picture above, there is such a thing as a minor and a cofactor. Minor or M is the determinant of the matrix whose elements have been removed. Meanwhile, the cofactor C or K has the formula -1 to the power of the element I plus j multiplied by its minor. It can be written as -1 to the power of I plus j multiplied by minor ij. For the example, if A has the elements like this, then determinant of matrix A is 1 multiplied by -2 multiplied by -8 plus 3 multiplied by -1 is equal to -2 plus 16 minus 3 is equal to 11. That way generalizes the larger determinants. For example, to calculate the determinant of a 4 by 4 matrix, we have 4 terms, each of which would contain a 3 by 3 determinant. The properties of matrix determinant. Let A and B is the matrix of order n by n. Determinant of matrix AB is equal to determinant of matrix A multiplied by determinant of matrix B. 2. Determinant of transpose of matrix A is equal to determinant of matrix A. We read A with C in superscript is transpose of matrix A. 3. Determinant of scalar K multiplied by A is equal to scalar K to the power of N multiplied by scalar multiplied by determinant of matrix A. K is scalar or real numbers and N order of matrix. 4. Determinant of A inverse is 1 divided by determinant A, or we read matrix inverse. 5. Rows or columns where all elements are 0, then the determinant of the matrix is 0. 6. 2 rows or columns whose elements are the same or multiplies, then the determinant of the matrix equals 0. Okay, next operation is the inverse of the matrix. The inverse of the matrix is the inverse of a matrix which, when the matrix is multiplied by its inverse, it becomes an identity matrix. Before finding the inverse of the matrix, we must first determine its determinant. The determinant is value that can be calculated from the elements of a square matrix. If a matrix has an inverse, it can be said the matrix is a non-singular matrix. On the other hand, if a matrix has no inverse, then it is a singular matrix. The symbol for the inverse of the matrix is to the power of -1 and is above the letter. For example, matrix B is the inverse of matrix A. So we write B equals to A to the power of -1. Or we read inverse of matrix A. And matrix A is the inverse of matrix B. We write A equals B to the power of -1. Or we read inverse of matrix B. Matrices A and B are inverses of each other. Formula of matrix inverse for order 2 by 2. The inverse of the matrix for order 2 by 2 can be directly obtained by, first, swap the elements on the main diagonal. 2. Second, put a negative sign on the other elements. Third, divide each element of the matrix by its determinant. The formula like this. For example, if A is 2, 5, 1, 3, then the inverse of matrix A is 1 divided by the product of 2 multiplied by 3 minus the product of 5 multiplied by 1. Then the quotient is multiplied by 3 minus 5 minus 1, 2 is 1 over 1 is multiplied by 3 minus 5 minus 1, 2. It's equal to 3 minus 5 minus 1 and 2. Formula of matrix inverse for order 3 by 3. Finding the inverse of the matrix for order 3 by 3 can be done in two ways, namely by adjoining and transforming elementary rows. An adjoint matrix is a transpose of a matrix whose elements are cofactor of the elements of the matrix. Then, the formula of matrix inverse for order 3 by 3 becomes inverse of matrix A is equal to adjoint A divided by determinant of matrix A, with determinant of matrix A not equals to 0. In determining the inverse of the matrix AN by means of elementary rows transformation, you can use the following step. First, the form of this matrix AN, where IN is an identity matrix of the order n. 2. Transform the matrix EN to the form INBN by transforming the row elements. 3. The result of step 2, obtain the inverse of the matrix AN, namely Bn. For the example, we can solve the problem of this question by transforming the row elements, and then we can get the result of matrix inverse. It is for 40 minus 40, 16, 9, 13, 5 minus 5 minus 3, 5 minus 2, and minus 1. Properties of matrix inverse. Suppose there are matrices A, B, and C, which has an inverse and is the identity matrix. First, inverse of the inverse of the matrix A is equal to a matrix A. 2. Inverse of matrix A multiplied by matrix A is equal to A multiplied by inverse of matrix A is equal to identity matrix. 3. AB is equal to I. It means matrices and A and B are inverses of each other. Namely, A equals to inverse of matrix B, and B equals to inverse of matrix A. 4. Inverse of the product of A multiplied by B is equal to inverse of matrix B multiplied by inverse of matrix A. 5. AB is equal to C when A is equal to C multiplied by inverse of matrix B, or B is equal to matrix equal sorry or B is equal to inverse of matrix A multiplied by C.
Okay, that's it for our presentation. Now we come to quiz session. If you guys can answer the question, please raise your hand. Okay, the first question. Okay, on my screen, there is Angga will going to answer question number 1.
Okay. The answer is B, element.
Okay, we'll see the answer of this question. The answer is B, element. Numbers arranged in a matrix are called elements of the matrix. The elements of the matrix are denoted by lowercase letters and given an index that states the location of the rows and columns. The answer is correct. Who's gonna answer this question? Okay, Siska, you can answer the question.
My answer is D.
Sorry, Siska, the answer?
D.
Yeah.
A is okay.
Let's see the answer of the question. The answer is A, which A equal to 15, B equal to 6, C equal to 24, and D is equal to 3. We can solve this question like this. Okay, the third question. Okay, on my screen there is Paul will answer this question.
My answer is D, -2.
Okay, we'll see the answer of this question. The answer is correct. We can solve this question like this. So x we got x sama dengan x equal to 3 and y equal to -1. So x plus xy plus is equal to 3 plus 3 multiplied by -1 plus 2 multiplied by -3, and the answer is -2. Okay, the fourth question. Okay, on my screen, there's Arif will going to answer this question.
The answer is A.
Okay, let's see the answer of this question. The answer is correct. 0. The next question. Who's gonna answer this question? Okay, on my screen, there's Aurelia.
Okay, my answer is C, -3.
Okay, let's see the answer of this question. Okay, the answer of the 5 question is -3. So the answer is correct. Okay, the last question. Who's gonna answer this question? Okay, on my screen, Arianti will answer this question.
My answer B, 5.
Okay, let's see the answer of question. The answer of the last question is 5, so Arianti's answer is correct. Okay, finally, we come to the end of today's presentation. I would like to say thanks again for the attention, and I want to say sorry if there's any mistake. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Now we'll move to question and answer session. If anybody want to ask, please raise your hand. Okay, if there is no one to ask, or maybe Ma'am Eliasari wants to add. Is there anything Ma'am Eliasari wants to add for the whole presentation?
Okay, thank you, Group 10, for your presentation about matrix. We still have a bit of time. Now, I want you to do some exercises, yeah? I'm going to put on the exercise here, and then I'm going to divide you into some groups with breakout rooms. It will be assigned randomly, so I don't know which one is going to be in which group. So please do the exercise. You have 30 minutes to complete the exercise. After that, please submit your work, yeah, here. So give me one moment to set up the assignment, yeah. Okay, listen, the exercise is already on Microsoft Teams, yeah. There are 17 problems, but you don't have to do everything, yeah. Only number 1, number 2, 7, 12, and 13. So only 5 problems, yeah. Do it in a group. Now I'm going to create the breakout rooms. So there'll be 3 to 4 people in each group, yeah. Before we open the breakout rooms, do you have any questions?
Maaf, Mem, boleh diulang nomornya?
Number 1, 2, 7, 12, and 13. Yeah, there's a description on the assignment. So if you click the assignment, you can see the description in there. And then you can just write the answer with your hand and then scan it, yeah, or take a photo of your answer and then submit it. Yeah, you don't have to type it all because this is a matrix, yeah, a bit difficult to type the notation and everything. Okay, is that clear?
Yes, ma'am.
Okay. Okay, now I'm going to leave you to work with your group. When you finish, please upload your work on the assignment. Yeah. Okay. Bye, everyone. Have a good group work, and I'll see you again next week. Okay.
Okay, ma'am. Thank you, ma'am.
Ma'am, izin bertanya.
Yes.
Sebelumnya untuk pengumpulannya perwakilannya aja.
Yes. Only the representation of the group.